Okay, so here it is told that in a game, a man wins rupees 5 for getting a number greater than 4 and loses rupees 1 otherwise. When a fair die is thrown, the man decided to throw a die thrice, but to quit as and when he gets a number greater than 4. Find the expected value of the amount he wins or loses. So here, let us say x be the random variable, which represents the amount the man wins or loses. So now here actually it can happen. So whenever he gets a number greater than 4 out of these 3 throws, so here it is told that the man throws the die, the man throws the die 3 times, means thrice, and he quits as soon as he gets a number greater than 4. So if he gets 5 or 6, then he will quit. Then he will quit the game. So, and if he gets 5 or 6, then he will get rupees 5 also. So then what can happen in the 3 throws? It can happen that in the first throw, it can happen first throw. What can happen in the first throw and what can happen in the second throw and what can happen in the third throw? So we can say that in the first throw, suppose he gets a number less than 4, means 1, 2, or means less than or equal to 4, means 1, 2, 3, or 4. And in the second throw, he gets greater than 4, means 5 or 6. Then he will quit now. So he will not play the third throw. Then in the second case, it can happen that in the first throw, he will get less than or equal to 4. And in the second throw, he will get again less than or equal to 4. And in the third throw, he will get greater than 4. And then in the third case, it can happen like in the um, first throw, he will get less than or equal to 4. And in the second throw also, he will get less than or equal to 4. And in the third throw also, he will get less than or equal to 4. So more than 3 throws, he will not play. So here also, he has to automatically quit. And in this third case also, he has to automatically quit. Since why? More than 3 throws, he will not play actually. The man throws the die thrice only. So more than 3 throws, he can't play. Okay, then in the fourth case, it can happen that in the first throw only, he gets more than 4, means he gets 5 or 6. So here he will quit. So then in the fourth case, it means that he will not play the second throw also, and he will not play the third throw also. So in the first case, what can be the values of x? The value of the random variable x, here it can be. So for less than or equal to 4, he has to lose rupees 1, and here he will get rupees 5. So it can be, this will be -1 plus 5. So it will be rupees 4 he will get. And then in the second case, it can be less than or equal to 4 in the first row. So here he will lose rupee 1, and in the second row also he will lose rupee 1, and in the third row he will gain rupee 5. So it will be -2 plus 5. So he will get rupees 3 here. And in the third case, he will lose rupee 1 here, and here also he will lose rupee 1. Here also he will lose rupee 1. So he will actually lose rupees 3. So he will lose rupees 3. So it will be minus rupees 3. And in the fourth case, he will get rupees 5. And these two throws he will not play. So it means he will get rupees 5 here. So therefore, the random variable x, the random variable x here can take the values, that is -3, +3, 4, and 5. Okay, so only these 4 values it can take. So now we have to find the p of x equal to -3. It means the probability of getting a number less than or equal to 4 in all the 3 throws. In all the 3 throws, he should get less than or equal to 4. So that will be in the first throw also he should get less than or equal to 4. So it means he will get 1, 2, 3, or 4. So we know that the probability of getting these 1, 2, 3, or 4, that would be obviously 4 by 6. Since when a die is thrown, then there are 6 outcomes obviously in each throw. 6 outcomes in each throw. Then the probability of getting 5 or 6, that would be like 2 by 6. So that would be 1 by 3. So the probability of getting a number less than or equal to 4 in all the 3 throws, that would be 4 by 6. So that would be 2 by 3. And then, no, sorry. So in all the 3 throws, so it will be 4 by 6 whole cube actually, 4 by 6 into 4 by 6 into 4 by 6. So that would be 2 by 3 whole cube. So that would be 8 by 27. And then P of x equal to 3. It means the probability of getting less than or equal to 4 in the first 2 throws, and greater than 4 in the last throw, means in the third throw. So that would be equal to, this would be greater than 3. Okay, so less than or equal to 4 in the first two throws, so that would be 4 by 6 into 4 by 6, and in the last throw, so that would be 2 by 6. So this would be 2 by 3 whole square into 1 by 3. So this would be 4 by 27. And then P of x equal to 4. It means that we have to find the probability of getting less than or equal to 4 in the first throw, and greater than 4 in the second throw, Since why in the third throw he will not play, he will quit here. So then that will be 4 by 6 into this will be 2 by 6. So this would be 2 by 3, so 1 by 3, so that would be 2 by 9. And P of x equal to 5. It means the probability of getting greater than 4 in the first throw itself. So after that he will not play. So that will be 2 by 6. So that would be 1 by 3. So therefore, now we can write, therefore, the required probability distribution of the random variable x. We can write the required probability distribution of the random variable x. So that would be x can take the values -3, +3, 4, and 5. So the corresponding probabilities will be for P of x equals to -3, that is 8 by 27. Then P of x equal to 3, that is 4 by 27. and P of x equal to 4, that is 2 by 9, and for P of x equal to 5, that is 1 by 3. So this is the required probability distribution. Then here it is asked to find the expected value of the amount he wins or loses. Therefore, we have to find the expected value of the variable x. So that would be summation pi xi, where I goes from 1 to n. So here the number of values of x is 4, so that would go from 1 to 4. So this would be p1 into x1, so this would be minus 3 into 8 by 27, plus this would be 3 into 4 by 27, plus this would be 4 into 2 by 9, plus this would be 5 into 1 by 3. So then from here we can see 3 9s are 27, 3 9s are 27. So here 9 will be the LCM we can take, and this will be minus 8 plus 4, plus this is 4 to the 8, then 3 3s are 9, 3 5s are 15, so this would be 15. So this 8 and 8 will cancel, so 15 plus 4, that is 19, 19 by 9. So this is the required expected value of the amount which he wins. Since the expected value is coming positive, so his expected value is that he will win. So he wins since the expected value of x is coming positive. So it is approximately 2.11 approx rupees. Approximately it is 9 to 18. Okay, so it is 2.11 approx. So therefore we can say that the expected value of the amount he wins or loses is rupees 2.11 approx. So this is the final answer. Thank you.